In this video, we're going to be getting our feet wet for the first time with AI intelligence. What we'll be doing is starting off with creating two states. That one will be a wandering state and one will be an attacking state. And these states kind of feed off of each other. They kind of go back and forth depending on the situation. These are very early beginning levels of AI. This isn't anything too involved. Later we'll be getting more involved with AI, but for right now this is just to get us started. The first thing we need to do is inside of function possess, well, you actually need to create this function. It exists inside the parent class. You could probably find it inside the controller class if you needed to. We do super.possess to keep the code that existed before. And then we're going to add a function called pawn.setMovementPhysics. What this is going to do is it's going to check to see where the pawn is in this current situation, and it's going to make sure that it's not floating in free space or something like that. We could also kind of physically set the physics as well. We could say, like, for instance, if the pawn is in the physics state of walking, make sure he's falling. And then what will happen is if the pawn's kind of sitting up there in la-la land floating, he'll fall first, and when his feet touch the ground, then he'll begin walking again. This kind of stops it. If you don't do this, what you'll notice is when you place these pawns in the map, there's a chance that they're actually not going to move. They're just going to sit there, and you're going to think it's your code, but what it actually is, it's really the physics of the pawn. It hasn't been set up properly. So another thing I want to mention real quick about super.possess here, or even any function in which you use the super keyword, if you put code before the super, that means you're going to run that code before you run the original code in the function. If you put code after the super, that means you're going to run code after the function. So basically, in this situation, we run all the previous code and then we run our new code. You could do it vice versa, and depending on the code, sometimes you want to do it after, sometimes you want to do it before. The next thing we need to do is we're going to go inside of our function restart, and when this gets called on, which usually happens after after like the pawn gets possessed and everything's ready to go, what happens is the game restarts the creature or the player, and that just makes sure everything's flowing together. So inside of here, this is where we're going to set our state. So after the player restarts, it goes to the state of wandering. Now later we might be adding some more things here, like if it's this type of creature, we don't want it to go to wandering. We want it to go to a different kind of state, and that's where we would probably do this as well. Okay, so now that we have our two functions that we needed just to kind of get things rolling, let's get into our first state, and that's going to be wandering. And inside of here we have a function called cPlayer, which we'll get to in a second. We have a begin state, which we're not even using at the moment. And then down here we have some code, which is a little different because we've never done this before. What we've done is we placed a begin label, which is needed to get it started. And after that you can kind of place your own labels in there. But the begin label, what that means is after begin state is run, it goes to this and checks here. Now if begin state's telling it to run functions, it's going to kind of probably do both. But you don't want to kind of jump around inside the begin state between functions unless you're not doing a whole lot. You should probably use the label you use here. So we're going to do begin, and then in here we're going to have a function called wait for landing. This function already exists inside of a parent class, and what it basically does is it makes sure that if the pawn is jumping, you wait for it to land before you continue on. It's a latent function, so in other words, it waits until it's done doing what it's supposed to before it moves on to the next thing. Our next thing is move target, and we're going to find a random destination. This is another function that's created inside of our parent classes. And find random destination, what that does is it looks for all these navigation nodes that we place in the map, and then it picks one at random that it can reach, basically, and tries to get to it. We set our move target to that. Move target is a variable also created in our parent classes. So as you can see, a lot of this stuff has already been created for us. We're just using it the way we want to use it. So it's very important, if you really want to get a good grasp of the things that you can already use that you don't need to recreate, is to go inside of the controller function, or I'm sorry, inside the controller class, and as well as the AI controller and any other parent class that might be involved, and really take a look at what kind of functionality exists already for you. So then we have a move toward function, once again, from the controller class. And in there we pass in two variables, move target and move target. What we're basically saying is we want it to move towards the move target and we want it to face the move target. If you don't put face there, then what it'll do is it could face somewhere else or do something that, besides what you want it to do. Then we throw in our own label called done wandering, and this actually doesn't even really get used, but it does let you know that at this point he's already moved towards his move target. After he's reached his destination, move target is also a latent function. He will go into sleep for 3 seconds, so it'll sit there for 3 seconds, kind of just not doing anything. But at the same time, that doesn't mean if a player doesn't it gets seen he's sleeping. No, he's actually awake. It's just he's not using this functionality right now for 3 seconds. And then after those 3 seconds expire, then we say go to begin, and then he finds another spot. If we don't put a sleep in there, what's going to happen is as soon as he reaches that spot, he's going to turn around and head somewhere else. He doesn't like sit and relax and look around kind of thing. He just heads right to the next spot. And that's why we use that sleep there. You might want to set this higher or lower. You might feel like you want him to continuously move non-stop. It's up to you. Okay, so after that, we can scroll up here. We can go into our function called cPlayer. Inside cPlayer, we have a few things. First, we have a local vector called hitLocation and hitNormal. We have a local actor, which is one of the very, very far up parent classes. The only thing further up than the actor really is the object, which we're going to call AC. Then we have a local blocking volume called BV. And what we're going to do is we're going to make sure if the enemy is equal to none. So really there shouldn't be a reason for this to be false, but you never know. If the enemy does equal none, then we're going to go inside of our function, or inside of our code here, and we're going to say if the scene player dot controller dot is a puz player controller. So if the controller of this scene player, which is the pawn being passed in, is a player controller, we're going to do this code. This is the same thing as if we did like a local puz player controller PC equals puz player controller pawn dot controller kind of thing where we typecast. And then we would say something like, instead of this, we would say if PC is not equal to none, do this code. It's kind of the same thing, it's just another way of doing it. Now, in here, we're going to do first. We're going to do a trace to see. So if the enemy does see the player, we want to make sure that that there isn't a blocking volume in the way. Because if there's a blocking volume in the way, we don't want this creature to see him. The way this game's set up is it's kind of like a maze, and in order for the maze to work with the camera, we can't set the walls too high. Normally the walls would get in the view of the pawn. So this allows us to make sure that the creature, the AI, doesn't see us even because the walls are too low. So we're going to see if there's a blocking volume in the view in the way of the viewing of the pawn between the player. And if there is a blocking volume, then we want to make sure he doesn't react. So we're going to say AC is equal to trace hit location hit normal, and then we're going to set it from the end location, which is the scene player, and then the starting location, which is the actual location of the pawn. BV is going to equal to the blocking volume AC, and then we just simply say if BV is not equal to none, return. So if there is a blocking volume in the way, return. Don't do any of the rest of this code right here. Just skip it, return, go away. Now, if it is not a blocking volume, if there is no blocking volume in the way, then at this point we set the enemy equals to the scene player. Enemy is a variable already created inside of our, I believe it's either the AI controller or the controller function, and then or controller class or the AI class, and then we go to state attacking. So what will happen is now if the player walks in front of the AI, and the AI does see him in a line of sight type thing, then at that point the AI will go to attacking. Now we don't have any weapons for the AI yet, but we can still at least follow the player. So inside of state attacking, our next state we're going to create, we have a few functions as well. First, we have the begin state and end state, which we don't put anything in at the moment. We have a function called attack enemy, and we have a function called enemy not visible. Down here, once again use the label begin, and we use wait for landing just in case if he's falling for some reason. And then we go to attack enemy, and then we use move toward. Now move toward is going to go towards the move target, face the move target, and then once again we go to begin. So we keep looping this around. We go back to the label begin. So first, like I said, we go wait for landing, then we do attack enemy. So this is a function we create. So attack enemy, we say if the enemy is equal to none, go to state wandering. So if for some reason we reset the enemy, if the enemy disappears for some reason, we don't want to be attacking him anymore because he shouldn't be. So we go to state wandering. Then we make sure that the enemy still exists as well, because otherwise this could cause an error in the code. So we're going to say if the enemy is not equal to none, then we're going to say move target equals enemy. And what that basically happens is we set the move target no longer to a navigation node like we did in the wandering state. We set it to the enemy itself. So he's going to walk right at you. Now the downside of this, of course, is if there's a wall or something, if you manage to go around a wall, he probably would walk right into the wall. However, if you did manage to go around a wall, we have what's known as a function called enemy not visible. At this point, if the enemy is not visible, then it goes to state wandering. Now, one thing we could add here, which I haven't yet, is the thing with the blocking volumes, because obviously he won't, the enemy not visible is not going to kick in unless you get around a wall that he can't see you. So there might be some error or bug with this, certain code at this moment, but at least you have the idea that basically this function enemy not visible does indeed set the pawn to back to wandering state, and then you reset the enemy to none because you don't want to have an enemy if you're in the wandering state. Okay, now that that's all through, the next thing we're going to do is we're going to jump over to adding more information to our AI. So first we're going to go into Puzz our Puzz character information class, and inside of there we're going to create some additional information. First, we have all these are constants because we won't be changing them. We have a collision radius, a collision height, a pawn scale, a normal speed, and a B-chem pickup. All of these things are variables inside of our players, whether it's an AI player or a human player, that need to be changed based on what they are. Because, for instance, not every creature is the same height, the same radius. Not every creature is going to need the same scaling, because you might actually put a model in that's too big and you want to scale it down. Well, you don't want to scale every model down. So we're going to set each one of these things individually upon creation. So we have like I said, we have our radius, our height, our scale. We're going to use normal speed for ground speed, and we're going to use B can pick up to whether or not this creature can actually pick up items. Obviously, the only person in our game that's going to be able to pick up items is the player. We're not going to let the AI pick up anything, but at least you know that you can set this if you want to. So we're going to go inside of our Puzz player information class now. And in here, we're going to set those to collision 45, height 75, scale 1, normal speed 220, and B can pick up the true. And then we're going to go inside of our enemy information class, and we're going to set that as well, 45, 45, 1, 220, and false. So you're going to obviously see that the collisions are going to be different. Now we need to set these things. So we're going to go inside of our Puzz pawn, and inside of set character information, we're going to add some more information. Down here, we're going to put in cylinder component, and we're going to set that cylinder size, and we're going to pass in that information that we have. So we're going to access it through the default because it is, once again, not only is it a constant, but it's also being pulled from a class variable. It's not being pulled from an instance variable. So you have to use something that's static, which is the default values. So we have puzzchartinfo.default.collision radius, and then also the height. We pass those in, and that will set the cylinder size for us, which is the collision cylinder that is created through our pawn already. You can actually see it in its original creation, I believe, inside the pawn class down in default properties. Then we have in here, we set our scale. Now we want to make sure the scale is not 0. If for some reason the person doesn't set this inside of our class, it's going to default to 0. We don't want that to happen. If it defaults to 0, then obviously a 0 scale could cause some problems. So we're going to make sure it's not equal to 0, and then we're going to set the scale. And then we have in here B can pick up inventory. We're going to set that also to that variable of whether B can pick up inventory. Now next, we have in here ground speed. Now this won't actually work because what happens is somewhere in the code, the game is resetting ground speed on the restarting of the player. So this will not work in here. So we need to take this out. And what we're going to do is we're going to place that in a different area of the classes that you wouldn't expect really so much, but inside of Puzz game. So we're going to jump into Puzz game, and we're going to go down, and we're going to create and use a function called restart player. And restart player is already a function created for us from game info, and even possibly even before in parent classes. And we're going to reuse all the code, and then we're just going to make sure that because it does pass in the controller, we're going to make sure that obviously the controller does have a chart info. It's not equal to none, and if it isn't equal to none, then we set the ground speed there. somewhere inside of restart player, or possibly maybe somewhere a little bit before restart player, the pawn, when it gets created, is being reset to its default status. So we need to override that default status. Instead of rewriting the entire restart player code, which could also cause a lot of problems with our game, we're just going to override what it kind of would override on us, so to speak, inside of our char info. Okay, now that pretty much will add all those additional things now that we can now manipulate our information class even further and get more, get more involved with that. Now, the next thing we're going to do is we're going to go inside of our Puzz AI controller again, and we're going to start adding some additional functionality that we'll be using later. First, we're going to add what's known as a stop moving function. What the stop moving function does is, in certain situations, such as when the game ends, you need to tell the AI to stop moving. If they don't, they're just going to kind of keep floating straight forward and not really, they're just not going to react to like the game actually ending. And we want them to stop moving. So that's what this comes in at. So we might throw this in certain, when the game's over, things like that. We're going to make sure they stop moving. Another thing is we can check the distance between the enemy and the player, or the enemy and another pawn. And that's where we get enemy distance, and the pawn is other. And what we do is we take the distance of the enemy, which is going to be a float. That's the distance between both enemies. It comes in as a float, and we're just going to compare the two vector sizes by and transferring it into a float. So we're going to take pawn.location, subtract it from other.location, and that's going to return a float value for us. And then we use that to know what the distance is in float version, so to speak. So if that could be very helpful for like line of sight. For instance, if we don't want the pawn but to see 300 units in front of him, then we can set that by first finding the distance and then saying, okay, if it's greater than or less, or if it's less than or equal to 300, then go ahead and see the enemy. Otherwise, don't see the enemy. That sort of thing. The next thing we're going to do is we're going to set what's known as an enemy status. So we're going to go up to the top here, and we have numerous variables. We have a variable float enemy acquired time, which is the time in which we actually saw the enemy for the first time. The last seen time, which would be the time in which we last saw the enemy. These are different because the enemy might still exist for a long period of time. He might go behind a wall or whatever, and at that point we would set the last seen time. But the acquired time we wouldn't reset because that's the time you originally saw this enemy. We have also enemy last location, which is the last location you saw the enemy at. We have enemy quit follow time, which is a float in which how long do you want the enemy to follow this person. So if you wanted the enemy only to follow this person for 10 seconds, you could set this value somewhere in there and decide, how long he will follow. We have last enemy target, which is the last target the last enemy he saw. This obviously will be set to the enemy, but then it'll after the first time. But after that, it won't be set to the last enemy. And then we have variable float current enemy distance, which basically you can use that where we just created that function. You can use that in there to know what the distance is between the enemies and hold that value if you want to use it for some reason. In this function here, we're going to actually set these values. So first we have, if it is a new enemy, we're going to set the acquired time, the last seen time, the last location, the last seeing position, and the last enemy target. And that's going to, that way we can use all of those. And then if it is not a new enemy, we're just going to set the last seen time, the last location, and the last seeing position. We don't need to set some of these other things, such as the last enemy target, because that at this point has already been set. Now we can reset the last enemy target in a different situation, because now when it's a new enemy, then we obviously need to set in the last enemy target equal to what the enemy was. Okay, so now next we're going to use what's a function called isNewEnemy, and what we're going to do is if it is equals a new enemy, then we're going to obviously return true if it is, otherwise we're going to return false if it is equal to the last enemy target. So these two functions can be used together, which we'll show later on. And that way you don't have to continuously rewrite this code and check if it is a new enemy, that kind of thing. And that pretty much adds all the extra functionality we need at this point, and then later we'll be getting into even more AI.